Today, I want to talk to you about concentrations in chemistry. So this is the fourth video, still part of this introductory section of the course where we're just going over the basic tools of chemistry. And concentration is really an important idea in chemistry and in life. So in concentration, we have some value that's essentially a property of the material that you have, the solution that you have, and then ultimately you're going to want to know how many moles you have given the amount that you actually took. But the concentration is, the concentration of salt in the ocean. That's a kind of uniform value that you're going to want to be able to know and to tell somebody else when you're doing an experiment. So the most common unit of concentration in chemistry is the molarity, which is moles per liter, and it's abbreviated capital M, molarity. And so 1 mole is simply 6.022 times 10 to the 23rd things. And this could be, you could have a mole of puppies if you were really lucky, but generally we're going to be talking about a mole of atoms or a mole of molecules. So that is the number of atoms in 12 grams of carbon-12, just as a definition. So over and over again, you're going to be asked to calculate the molarity of a solution where you're going to want to know the number of moles per liter. This semester in chemistry, the liters are almost always going to be of water or some other aqueous solution. Next semester, when you're taking organic chemistry, it'll almost never have anything to do with water. It'll be some organic solvent into which your molecules of interest are dissolved. So let's just take an example, and this example will both help us with some math and also with appreciating the importance of concentration. So what if we thought about sugar in sodas? I've probably read a lot about the concern about people drinking too much sugary sodas. So I looked this up this morning and found that there were 77 grams of sugar in 20 ounces of Mountain Dew. And I guess the website I was looking at suggested that Mountain Dew was a particularly sugary soda. So the question for us is, what is the concentration of sugar in moles per liter in Mountain Dew? And then once we know that concentration, how would we use that to calculate the actual number of moles of sugar that you're going to consume depending on how much Mountain Dew you drink? So as with everything we've done so far this semester, getting between grams per ounce and moles per liter is simply going to involve a series of systematic magic ones. So I have 77 grams of sugar in 20 ounces. This is what the website tells me. And so now I'm going to need to convert between grams of sugar and moles of sugar. And I have to actually know the chemical formula for sugar. And the most common sugar is glucose, which is C6H12O6. And I would not expect you to know that just off the top of your head, but you could look that up. And then you could find the molecular weight for that, which is 100 point something, 100.156, or we'll just round up, 108.6 grams of glucose in 1 mole. And then we'll need to be able to convert between ounces and liters. And again, we need the magic one that relates ounces and liters. And again, I wouldn't expect you to know this. I didn't. I had to look it up. 33.814 ounce is 1 liter. So again, just to remind you, this is a magic one. This is a magic one. These are both equivalent statements. And then I watch, as always, check my units. Grams cancel, ounces cancel, and I should be left with moles per liter, which is what I want, and I am. So then I just do the math with confidence, and I find that that's approximately 0.66 moles per liter, or 0.66 molarity. Okay? So that's a pretty straightforward but not so simple application of our Magic 1. Now, before we go on, one of the things that you really want to get into the habit of doing this semester is to just think about the order of magnitude of your problem. So anytime you're doing a mathematical problem, you've systematically used a series of problem-solving steps that you're confident of. Even still, you want to just take a moment now and say, does this answer make sense? Well, so let's just look at this, and I think I'll get a slightly more visible color here. I started off with 77 grams of sugar, and I see that 1 mole is 180 grams. So just order of magnitude, I have about a half a mole of sugar at the beginning of my problem. And I have that in 20 ounces, and I see that 33 ounces is a liter. So I have about half a mole in about 2/3 of a liter. And so just without doing anything, without getting my calculator out, I'm going to expect that my final answer is going to be slightly more than a half a mole. And in fact, so I expect that my answer is going to be greater than 0.5 moles per liter, but that order of magnitude, and I see that it is. And that approach of just thinking through the order of magnitude of things can really be a huge help and can save you from a lot of problems where suddenly you end up here with something that's 1 times 6 to the minus 24, and you're just wildly wrong. So take a moment and think through whether the order of magnitude makes sense. Okay? And then once you have that, so now you've converted between grams per ounce, moles per liter, again, our standard unit of chemistry. Now you want to ask yourself, well, how much sugar am I getting in my diet from drinking Mountain Dew? So if you were to drink a liter of Mountain Dew per day, then you would be drinking 0.66 moles. So 66 moles per liter is the definition of molarity, moles per liter. So if you drink a whole liter of soda a day, you're drinking 0.66 moles. But if you only drink 1/10 of a liter or 100 milliliters, then liters cancel, and you'll find that you're drinking 0.66 moles. So hopefully that little example helps you to appreciate the importance of thinking about concentration as kind of a general principle. And then from that general principle, you can always multiply it by your specific case. How many liters did you drink? Or in the case, more chemical case, how many liters do you actually use in your chemical reaction to find the actual number of moles? Okay, so that's the most common set of units, which are moles per liter. We're going to take a moment now and just go through a couple of other units which are a little less common, but which we're going to want to be familiar with.